Example 6, the weekly revenue in dollars from the sale of a product varies with time according to the function that. All right? So, weekly revenue in dollars, so R of X is the revenue, that's how much money we're taking in. And X is the number of weeks that have passed since the product was put on the market. So here's X.
So it's like slowly less interesting.
Yeah, so as X gets bigger and bigger and bigger, let's consider what's happening here. X gets much larger, that becomes a negative larger number, right?
Yeah.
And 14 over a negative number, right, is going to end up, as the number gets bigger, but it's not a negative number, but it's going to be over a number.
Over a number. Yeah.
It's going to get a bigger, bigger, bigger number here, right? So 14 over a really large number, eventually this goes out to 0.
Yeah,
So that's what's going to happen. So, but then we don't have to figure that out. All they're asking us is what will the weekly revenue approach as time goes by. They want X to get bigger, bigger, bigger. So the number of weeks, X, is going on infinitely. All right, what's happening? So they're asking is there a horizontal asymptote here. So if I go to my calculator again, go y equals, and I clear that out, and I type in my equation, which is 1760 on top, divided by parentheses, and then 8 plus 14e, so again that's second ln, negative 0.03x, end parentheses for the e power, another end parentheses for the denominator. All right? So that's our equation. And if you just take a look, go to our table first. Let's get rid of that. All right. So at week 0, the initial offering of this object, we're getting a revenue of $80. After 1 week, it's $81.53. After 2 weeks, $83.08. After 10 weeks, $95.80. After 20 weeks, $112.22. 52 weeks, which is a year, $160.85. So the revenue's going up, right? It's increasing. And we're feeling really good about our product.
The best product.
Revenue's going up. This is awesome. This is great stuff. But, you know, it started off at 80. Now we've doubled it after a year. If we go 104, which is 2 years, that gets us to 204. It's another $44. But so the first year was an $80 jump. Now it's only a $44 jump into the second year, right? Okay, what we want to do is, as time goes by. So again, if I look at a window, we go from 0 to 1,000 again. All right. Now we know we started at 8. I'm going to go minimum 0. I just like that. Now going back to my table, I got all the way up to 204, but it seems to be a $44 jump. If I go to the third year, that'd be 156, right? 156. Now we're at 216. That's not much more of a jump, is it? So it seems to be low. So I'd say if I go maximum of 250, I should be pretty safe, right? 250. Hit graph. And we can take a look. You can see this thing again levels off. So again, it's a curvy graph, but eventually it goes straight horizontal, which tells me that there's a leveling off point. That's what we're looking for in a graph. So we extend this thing on a lot. The graph has this really sharp turn, and all of a sudden flat lines. It doesn't go any further. Okay. So what we want to do is find out what that number is, and the way we do it again is we pick a big number. Pick 1,000. And 220 is what it comes out to. Now consider this again. If I do this, if this is 1,000 here, I've got 14e to the negative 0.03 times 1,000 is 30th, right?
Yep.
E to the 30th power is huge, right? So 14e to the negative 30 is actually 14 over huge, right? I don't, e to the 30 is just giant, but let's look at what it is. If I type in e to the 30th power,
That's going to be
huge, right? 1.06 times 10 to the 13th power. Like 10 trillion, 11 trillion, somewhere in there.
That's a good number.
Pretty large, right?
And then back on 14.
All right, if you do 14 divided by that number, it's 0.1101. All right, so it's basically it equals 0.
Yeah.
All right, so this zeroes out. 1760 divided by 8 is left, which equals $220. So what will the weekly revenue approach as time goes by? $220. Okay. The purpose of this problem and problems like this is to get a visual graphical representation of one of these functions. So you want to see, is that not right?
We have A,
We have
B,
A,
C.
B, and C.
You have A, B, and C. What's B and C?
Well, A is what was the revenue immediately after the product was put on the market.
Wow.
B is what was the revenue 1 year after the product was put on the market. And C, what will happen to the revenue as X increases without bound.
All right, so that's the C part. This is C, right? So the revenue will be $220 per week, right?
Yep.
All right, so A was, what was the initial
Yeah, immediately after.
immediately after? So that means as we introduce the product, we're looking for the revenue at week 0. And that was just, was it $80?
Yeah, it's 80.
And after 1 year, right?
Yeah.
Yep.
That's R of 52. And be careful with this, when they give you stuff like this,
25.
know that X is the number of weeks, and it asks after a year, which is 52 weeks. So if they're giving you some unit at a time and they're giving you a question in a different unit of time, make sure that unit changes, right? R50, was that 160.85?
25. Well, that's rounded, of course.
Yeah, anytime you deal with money rounded 2 decimal places, 80 was exactly 80, and 160.85 rounded 220 was exactly 220. Okay, as time goes by, that's what would approach. Because again, as time goes by, this number goes to the bottom, bigger, bigger, bigger. So 14 over that number, 14 stays 14. As the bottom keeps getting bigger, you see closer and closer to 0. This term goes away. All that's left is those two numbers.